I don't know. Okay. Then I gave my student teacher my schedule, so okay. So here we go. Find the domain. What do I look at when the question says find the domain?
Denominator, square root.
Denominators and radicals. Love it, love it, love it. So this one doesn't have a radical, but it has a denominator. And I know the denominator cannot be zero. So when I solve that, x cannot be 1/2. So my domain is everything except 1/2, right? So negative infinity to 1/2, or 1/2 to positive infinity. Right? Okay. How about b? Oh, b has both.
Oh.
So I know x plus 4 cannot be 0, so x can't be -4, so on my number line, -4 is going to have an open dot. And then 2 minus 3x has to be positive, right?
Right.
So -3x is greater than or equal to -2, and x is less than or equal to 2/3. Did you catch the switch of the sign? Right, yes, this is where I did.
I did.
So I'll put 2/3 here. And I'm less than 2/3, but I gotta skip over the -4 because I already put an open dot there. With me?
Yeah.
So negative infinity to -4, or -4 to 2/3 with a bracket at the 2/3. How about C? C of x. X minus 3 has to be positive, right? So x has to be bigger than or equal to 3. So bracket 3 infinity, is that okay? You don't have to sketch on the number line, but sometimes it helps. So feel free to sketch on the number line if that helps you. And what about these?
All reals.
All reals. Only we don't write all reals, we write negative infinity, comma, positive infinity with parentheses, right? How come that one's all reals?
There's no denominator or square root.
Oh, Joe Garvey, you are on fire today.
Had to become an upside. I think it was a donut.
I didn't have the donut.
All right, here we go. Now we're going to do our piecewise function. All right, so here we go. Now, when you are a piecewise function, that means you are broken into pieces. And this part reveals the break, the crack. So the crack, where this picture breaks apart, is where x is 2. Okay? Now, what does this mean? This, remember, this is y. So this literally says, this top row, literally says that y equals 5 if x equals 2. Isn't that just a point? That would be the point 2 comma 5. Nice solid dot right there at 2 comma 5. This says y equals 5 if x equals 2. So if x is 2, y is 5. That's a point, 2 comma 5. this say?
Y equals X plus 4.
Y equals x plus 1. Now wait a second.
Line.
X plus 1 is a line with a y-intercept of 1 and a slope of 1. So that line looks like this.
It has less than
It intersects the crack right here at an open circle. And I only want the part of the line, remember I broke it. I only want the part of the line less than 2. So that would be this part right here. Less than, left. The left part of the picture and keep it. The other part's going away. Okay? And then finally, this one says y equals negative x,
So it's at 0.
which is this line, a slope of negative 1, so down 1 over 1, down 1 over 1. It intersects right here, open dot. So again, now that line is broken. Do I want this piece of it or that piece of it?
Bottom.
Bottom piece. How do I know I want the bottom piece? Greater than. Right. Now, if you want to erase your crack, there's your picture. When you do a piecewise function, all the dots should be in a row, lined up, and only one of them can be colored in. Because you gotta have a function. Alright, so alright with everybody? Find vertical, horizontal holes. And intercepts. Add that on there. We need to add intercepts. So we're gonna find vertical, horizontal holes and intercepts of this guy. So in other words, we're gonna find vertical asymptote, horizontal asymptote holes, x-intercept, and y-intercept. And by intercepts, we mean where we cross the x and y-axis, yeah. Okay, factor, love it. What are you gonna do first? Take out a 3 on the top and a 2x on the bottom. GCF. Does that look good? And then I think we can factor more on the top. Bottom's done. What can we do to the top?
X plus 4, X minus 1.
X
X plus 5.
plus 5, x minus 1.
I thought my schedule got switched to my head. I went to the wrong place. I know, I'm sorry.
So when did it occur to you that you were going to do it?
When I saw, I asked someone that I thought was in my class. They were like, what are you doing? Not in the right class.
All right, you're here now. Okay, here's a paper. And it's back to her. Okay, so, oh, what did we notice?
There's a hole.
We're gonna have a hole because we can cancel. Guys, you aren't ever gonna have a hole unless you can do this. Now, this is what's left. The hole is a point. And it will be at the x that got canceled out. So the x value that got canceled out is 1. The hole is a point. All right, are we clear on where that came from? Okay, now let's look at what's left. If you have a denominator, you're gonna have a vertical asymptote. This comes from the denominator. So the vertical asymptote is gonna be at x equals 0. Where's the horizontal where's the horizontal asymptote gonna be?
1.5.
Y equals 3/2 or 1.5? Now, this sounds totally crazy, you guys probably don't need to be reminded, but your asymptotes are lines. Okay? So they need equations. If it's vertical, it crosses the x-axis, x equals. If it's horizontal, it's y equals. All right, now I need my intercept. Okay? Where are they gonna come from? How do I find my intercepts?
Plug in zeros.
So I go back to my equation right here. And to get my y-intercept, these are points. These are points. And to get my y-intercept, I have to let x be 0. So I'm gonna put in 0. What am I gonna get?
Wait, we're getting wired.
Wait. Wait.
No,
I have an asymptote at x equals 0. Can I put in 0? We have no y-intercept. Because we said we had an asymptote there, and look what happened when we tried. What happened when we tried? Didn't work. Didn't work, undefined. So we don't have a y-intercept this time. Do we have an x-intercept? Can we let y be 0? Okay, bring this over. Isn't that still 0? Divide by 3. And subtract 5. So my x-intercept is at -5. Most of the time you'll have a y-intercept, but not if you have an asymptote there.
But the only time that we wouldn't have a y-intercept is if
You have an asymptote there. Yep, okay. Sketch, state domain, tell if we're bounded above, below, or both. Okay, this sounds complicated. Okay. So let's start with the sketch. Y equals sine x minus 1. This is a no calculator exercise. Well, this whole test is no calculator. So we gotta remember what a sine looks like. So I'm gonna do my whole original sin thing. This is not the right picture, guys, this is the original sign. Agreed? What's the high point of the regular sign? 1, and the low point? Okay, perfect. So what you basically have here is, these are not asymptotes, I'm just drawing in. These are like the ceiling and the floor. Right? Now, what does this tell me to do?
-1, so the 1 will be 0.
So it's gonna drop the whole thing down 1. So now, my new ceiling will be at 0, and my new floor will be at
-2.
-2. Everybody good with that?
Yeah.
And the point that was at the origin, it got dropped down too. got that also. So it's gonna be right here now. So my hills and my valleys are now oscillating between -2 and 0.
Why does your picture look different on the bottom?
It doesn't. I just have that line drawn across the middle.
You have to draw that line or no?
You don't have to. You can if you want. I mean, that's what it's oscillating across. But as long as you mark your ceiling and your floor, you should be okay. Oh, now I gotta answer the rest of it. What does it say? State the domain. What's the domain of this thing?
Negative, all day.
All the numbers, that's right, negative infinity to infinity. See these arrows? They're just gonna keep going forever and ever and ever. Is this thing bounded above, bounded below, or both?
Both.
So we're gonna say it's bounded above at y equals 0. Wasn't that our ceiling? And we'll say it's bounded below at y equals -2. And if you are bounded above and below, you are considered bounded. That's what bounded means. You're above and below. So this is bounded. So you have this answer, and this answer. All right, we're gonna next two to finish this part here, B and C, and then you can go to lunch. Okay. So here we go. What shape do I have for my next one? A parabola. But it's not vertex at the origin. It's been moved left
left.
2. You guys right? Good with that? Okay. Now, domain, everything. We're gonna write that, but yes, everything. Bounded above, no.
Below.
Below, at y equals 0. That's as low as it goes. So it is not bounded, because to be bounded, you have to be above and below. There we are. All right, and finally, that's,
So you go to the right two.
you don't go to the right two.
Up to.
You go up to. Okay, so remember, boys and girls, Jake S. This would move me right, or that would move me right too. Okay? All right, so the normal, you gotta get this picture somewhat right, guys. The normal cube looks like that. So it comes, watch my hands, see how my hand's moving? And then here it switches and goes like that. Well, now that switch is gonna happen up here. Right, up to? So here's the first part, like a parabola opening down. And then I switch and I have a parabola opening up. And I label that point. And we're good. All right, they gave you short lunch today. I need you back at 05. 05. Sorry, everybody gets a short lunch today. Have you taken the quiz yet? Okay, well, you can come look at it, yeah, sure.
Okay.
But we're not redoing it.
I know, I just wanted to see if there's something I could.
Well, what you can do is do super well on this test now.
Yeah.
But remember, the test is worth a ton more points.